Okay, hi. So I want to make a video about to talk about the problems of the week and how I want them to be solved and what's the purpose of them. I feel like there's some confusion among a few students because they don't look straightforward from the work you're doing, and that's exactly what's happening. So, for example, this is probably week one. I'm not going to solve it carefully. I'm going to, I don't know, tell you what the number one is a straightforward problem from the book. We have talked about this. We'll talk about this in the first homework. It's about the difference quotient, and I can point to you what the common errors are. But when you plug in x plus h, you're saying that you're replacing every time you see an x, and the function up here becomes an x plus h. So it becomes 3 times x plus h quantity squared plus 3 times x plus h, right? So very bad h. So this is f of x part. This is this part. Then I need to subtract f of x. So I need to subtract 3x squared plus x. And I wrote this like that on purpose. This is wrong. Why is this wrong? Because if I leave it as it is, I'm only subtracting the first term. And I should be subtracting, sorry, hard to make that 2 in here. The small 2 is hard. There you go. I should be subtracting the entire expression, right? So this is the f of x part. And then you should divide everything by h, so it should be all that divided by h. So one common mistake here is to, wow, terrible h. One common mistake here is to not include these parentheses, so that would be totally wrong, because if you do not include these parentheses, then this sign right here would stay positive, and because of this parentheses, this is going to become a negative, right, after you distribute that. So that's the first thing to be careful with these problems, and this one you have to write that down. Then of course you have to expand this correctly. It's x squared plus 2xh plus h squared, distribute the 3, and so on. I'm not going to do it. So you can post the answers to it carefully if you want, but that's not the purpose of my video. Then on problem number 2, it's the same idea. Let me just write down the setup again. I'll just do that part. I can post the correct answers later carefully. I just want to do this one, so I want to tell you that what the setup for this one would be, let me do the same color thing. So my first point is to do f of x plus h. Oh, sorry, this is totally wrong. Something's wrong up here, right? This is not that. This is the difference quotient. Okay. So what I did up here, to be sure what I did f of x plus h. Then I took away in red f of x. That's what I meant to write, right? Then I'm dividing by h. So this color coding thing makes perfect sense, I hope. Okay? Let's do the same thing here. So I'm going to do in green my f of x plus h. So f of x plus h in this case would be, oh sorry, let me erase that. That's what I did last time. Then I'm going to do minus, maybe the red, f of x. And after that, I'm going to divide, right, by h. That's what I need to do. So let me see if I can write this down here. Here. Okay, so write that down. So this would be 1 over, instead of x, I need to write x plus h. After that, I add a 1. I didn't write a parenthesis here. You can write a parenthesis between x plus h if you want, but you don't need to. I mean about here, right? I don't need that one, right? Because that one is not going to affect anything in the denominator. Then I subtract f of x, so I subtract 1 over x plus 1. And then I divide all that for h. Now this part about dividing by h looks terrible if you do it here. It looks pretty ugly if you do that. It's fine. I mean, this is perfectly correct. This is the exact thing that's written up here. But visually, it looks very complicated. So just a little hint for these problems that involve fractions would be, this is the same, but I have it up here. This is the same as having it like this. 1 over h times, put that in here, right? F of x plus h. So if you write like this, it looks 10 times easier. Sometimes just knowing how to write it down so we don't get that confused helps. So if you do this in our problem down here, it looks a little bit nicer. Instead of doing that, why don't we write it like this? All this, then multiply by 1 over h. That's the same thing as a difference quotient, right? Then how do you work this out? Well, you have three terms here. You're going to have to do like the 1 over h is still outside. And then inside, you're going to have to write the common denominator. I'm going to forget about now the colors. It's going to be, my common denominator is going to be x plus h plus 1 times x plus 1. And over here, I need to, this fraction I multiply top and bottom. This fraction over here, I multiply top and bottom by this denominator, right, to make it the common denominator. So it becomes x plus 1 over here. And now this fraction over here, I multiply top and bottom by x plus h plus 1. So this would be like this. Okay, so this is what happens. You have to, if you look, I can keep going if you want. I'm almost done in this case. The numerator simplifies a lot because once you distribute this negative, the x's are going to cancel. Let me see if I can, I don't want to write too much here, but the x's are going to cancel because it's negative, this one. The 1's are going to cancel because this is, with this negative becomes minus, so that one cancels. And then also lies in the top is a negative h, right? And in the bottom you have these two guys still here, so you can write that in here. X plus h plus 1 times, if I can make this fit, x plus 1. There you go. I can't close the parentheses yet, but it's right there, okay? A 1. Oh, man. Okay, it's a 1 right there. Then one more step, you cancel the h's, and it's negative 1 over that denominator. There's no need to multiply this for those who have taken calculus, so if you know what happened in the next couple of weeks, you take the limit when h goes to 0, so this becomes x plus 1 squared in the bottom. So there's no need to distribute this product in the denominator. You can leave it like that. That would be the final answer in this one. Negative 1 over x plus h plus 1 times x plus 1. So it's not that hard. If you see this after doing this idea of writing this difference quotient as 1 over h times that, this makes things a little bit more clear. Okay, now what I want to talk about, really. So these problems are straight from the homework. They're similar to what you did in the homework. I just need to check that you're doing this in the correct way and give you some feedback. But the problem, my intent of doing problems of the week is that with these, some of you know this from taking the previous online class with me. The problem with the online class is that it gets to a point where it seems like all you are doing is solving problems from the textbook, and knowing how to solve specific problems from the textbook will let you pass the class. And that is true. I mean, you will pass the class if you master how to solve the problems from the textbook. The problem is that in a regular face-to-face class, that is not the same intent. In the regular face-to-face class, we do a lot more than that, right? There's a lot of interaction between the students, there's a lot of questions, there's a lot of things of how this connects to other classes, how this connects to another area. What is a more general situation where this happens? I can give you examples that are out of the textbook. I can make my own problems, my own worksheets. So these problems of the week are my way to fill that little gap of, it's not just textbook problems. And also in a regular class, I would have the opportunity to give you some insight of what's going to happen next. I can give you a worksheet today in class that makes you think a little bit of something we have not quite covered in class yet, but that will prepare your mindset for what's going to come next week. And it's not that I'm struggling and messing with your brains. It's more that I want you to see that, oh yeah, that's the natural thing to follow. That's the idea that would come in. If I was doing this, studying this on my own, I would come up with, that would be the next question to address. And so that's kind of what I want to do with the Planner Week. And I think it's hard to give that across, that idea, if I just post them and you guys work on them and you don't know what my intent is. And in particular for this problem over here, I said here, before taking this class, did not know how to find a tangent to a problem. And what I mean by that is everybody has an idea what a tangent to a circle is. And sometimes a tangent to a circle, people say, if I ask you what's a tangent to a circle, many people would answer it's a line that touches the circle at only one point. And that's the correct answer for a circle. The problem is that could not be the answer for a parabola, because I mean, if the parabola looks like this, clearly you don't want the line that touches it at one point, because this is a line that touches it at one point, and that's not what you mean by a parabola. By a tangent, right? So it's not enough to say that if it touches at one point. So we need to, and now you know by now that, what is the expression that we want for this, what is the expression that we're doing for this problem. So what we wanted to do is figure out a way to use the knowledge you know from before in order to define the tangent for parabola. So the whole point here is that for a parabola, you know what a tangent looks like at a certain point. For example, this parabola will be upside down because it has a negative, so let me erase it. It will be a parabola that looks something like this. Maybe its y-intercept is 6, I think. So it goes something like that, and it goes up and down. The only point you know how to find that you're very familiar with is this point. It's the vertex. And the vertex of the parabola, the tangent will become, oh sorry, it's hard to draw, a horizontal tangent. So that's what this problem was about, to just think about, I know for parabolas how to find tangents only at the high point or the low point. And what would you do? You find the vertex, it's negative b over 2a, you know that from your previous classes, the vertex is there, it's the x value. Then you plug it in to get the y value, and then this line is just y equals that y value, right? The y value of the vertex, because it's going to be a horizontal line. So this is y equals c, where c is the y value of the vertex. So that's what this was about. I saw a couple of your POWs using derivatives, doing things very complicated, and no, there was no point. So this led to the discussion that some people said, you need to read ahead in order to do the puzzle week. And no, you don't. If you read ahead, you would probably know how to do this, but that was not the point. In fact, I did not want you to use any calculus in this class. It says here, without calculus, tell me what point you can find the tangent. So in the next problem of the weeks, some of them are going to be reviews and stuff, but if you feel like you need calculus, and for those of you who have already taken calculus class, and you feel like I can do this with calculus or more things we see before, sorry, that we're going to see later, I'll try not to. The intent of this is like to make you guys think what is a tangent, and for problems in a special case you can find them without calculus. Okay, so I hope that clarifies what the intent of the part of the week was, and I hope that that makes you feel that from now on, what are we doing with Puzzle of the Week, and you don't feel totally lost. Okay, now one more thing. Please ask questions. I'm happy to respond, give you feedback on some problems. I had only very, very few questions, and also I'm available for office hours, so stop by my office if you are around. Okay.